Today's lesson from section 2.4, operations with functions. You can see our objectives here. Perform operations with functions to write new functions. Operations would be adding, subtracting, multiplying. And find the composition of two functions. We will show you a new symbol and what a composition actually is. So, operations with functions. Let's pull out these different functions and talk about each one specifically. Okay, the first one, a function f plus function g of x is the same as taking the first function, f of x, and adding it to the value of the second function, g of x. So we will be showing some examples of this in our work. Second one, f of g of x is an example of a composition. This is f times g of x. We would take each individual function and we would multiply the two of them together, and the resulting answer would be our product for these two functions. F minus g of x is nothing more than taking each separate individual function and subtracting those values at x together. That leaves our fourth one. And our fourth one is f of g, f divided by g of x. And you can see the function f of x being divided, and it does assume that g of x cannot be 0. If you remember, we learned that you can never divide by 0. Your denominator in a fraction cannot be 0. So the same thing applies here. Whatever the value of g of x is, as long as it's not 0, we would be able to continue to work this problem. So using those properties to actually evaluate some functions. Now, one more definition. The composition of a function, if f and g are truly functions and they're being evaluated at the same variable x, then the composition is said to be f composite g. That's what the little circle stands for. It's a composition, so new symbol right here, is defined by f of g of x. There's an order here that is determined. This reads f follows g in our function. So little circle interpreted, translated as follows. So if we look at this, f follows g of x, you come down to this version, you say g is the innermost parenthesis, and the innermost parenthesis, as we learned with order of operations, always means do first. So g of x would get done first, and then that answer would go into the f rule and be evaluated further. So f follows g, and both of them are evaluated with the value x. So we're going to try a couple properties as well as a composition. So look at this first one. We have f of x is our function, and according to this, we have no value for x. So all we're supposed to be doing is finding f plus g. So if we look at that, we take the function f, 4x squared plus 6x minus 9, and we add that to the function g, which is 6x squared minus x plus 2. If we start looking at that, based on things we learned in algebra, we should recognize there are some like terms. We're going to underline those like terms, and as we do, start thinking of what they would combine into. and write our final answer. So 4x squared plus 6x squared is 10x squared. 6x subtract 1x is 5x. And then 9, or negative 9 if you'd like to think of it that way. Subtract 9 or plus a negative 9. Add 2 to that, and you're going to get a negative 7. So our final function of adding f plus g is the trinomial 10x squared minus 5x minus 7. Second one, part B, says find f subtract g. And one thing you got to remember here, we're working with trinomials, and if we're going to subtract, order matters. So if we put our functions down again, and we would start with 4x squared plus 6x minus 9 is our f function. You may even want to, in this case, put some parentheses in just to show you. Then we're going to be subtracting that whole function g from it. So 6x squared minus x plus 2. So in this case, we're going to talk about using our distributive property with the subtraction sign. Everything that follows the subtraction sign must be subtracted. So you have a couple choices. In your head, I'm going to say 4x squared minus 6x squared, which would give us a negative 2x squared. You have your 6x minus a negative x, so minus a negative is plus a positive, so 7x. And then subtract 9 or negative 9 minus 2 would give us a negative 11. And again, that trinomial is your final function to represent f minus g. So we did an addition, we did a subtraction. Let's go ahead and do a composition and a division. Now, let me just check one thing. We're going to call this actually a multiplication. So we're going to consider this to be a solid dot. So it's going to be our multiplication of two functions. So again, 9x squared is our function f, and it should be multiplied by our function g, which is 4x plus 3. Should have seen this in Algebra 1. Think of it as a monomial times a binomial. And you usually just distribute on that. So that's where we head next. If we distribute 9x squared times 4x, we would get 36x cubed, and 9x squared times 3 would leave us with 27x squared. No like terms, therefore your final answer, 36x cubed plus 27x squared. It says state any restrictions. There were no restrictions because we were multiplying, nothing became 0. But in this next one, we can already see, look at this, we have a g down below, and that g down below basically cannot be 0. So that's another way of saying our 4x plus 3, which is g, cannot be equal to 0. Which means if we solve this, let's move the 3 to the other side first. That would give us a negative 3. And we divide both sides by 4, and we would get x is not equal to a negative 3/4. That would be our restriction on this one. The other part of it is we need to write the actual f divided by g function. So f is 9x squared. We will divide that by the g, which is 4x plus 3. So if we wanted f of g of x, write it out like this. And we'd look at that and say, is there any division we possibly can do? The number 9 does not go both into the 4 and the 3. Nothing we can do there. The x squared does not go into both the 4x and the 3. So our final evaluation is that. Our restriction is the x cannot equal -3/4. Last examples are doing a composition. And the composition, as we said, is like f of g of x, and that's the order this one's in. So f follows g of x, which means you must evaluate the g rule first and then follow it with f. So that's our thinking, versus over on this one with the order being changed, we would do g of f of x and evaluate that. Okay, let's do this first one. The second one we'll save and have it as part of our discussion. You can try it on your own and bring it to class as part of our work. So we want to start with the g rule. Well, the g rule is 2x. There's nothing I can do with that because we're not putting a variable in, but it is 2x. Now it would then read, I want the function f evaluated at the value 2x. So find your function f, x squared plus 4, and wherever there's an x, so our function, let's just do it this way. Our function f is x squared plus 4, and according to our notation, we must put in 2x wherever there is the variable x. So 2x quantity squared plus 4, do the math, 2x squared, 2x quantity squared is 4x squared plus 4. So there is the composition of f of g of x, simplified. Some people would say, well, can we distribute and take the 4 out? You could. They're not going to probably have you do that at this time, but it would also be equivalent to 4 times the quantity x squared plus 4. So the second one you work out. It's a little different order, and we'll discuss it in class and see if you've got the idea of how functions work, along with any other questions about compositions or the properties of functions.